Hey there. Welcome to a deep dive into a potential scientific discovery so huge it might sound like we're in science fiction territory.
Yeah, the research paper we're diving into today is pretty wild. Feels like a sneak peek into the future of physics, almost.
Exactly. And you wanted to learn more about Particle 11, right?
Right.
Now, I'm no physicist, but even I got chills reading this thing.
Yeah.
It could change everything we thought we knew. Energy, dark matter, even other universes.
Okay, let's not get ahead of ourselves. Still very early stages.
Right. Gotta stay grounded. But the paper claims this particle could generate over 1 non-alien, that's a 1 with 30 zeros after it, more energy than a nuclear power plant.
Wow.
If that's not worth a little excitement, I don't know what is.
I hear you. That energy potential is definitely a big part of what makes Particle 11 so interesting. Figure 1 in the paper really shows that.
Yeah, that graph comparing Particle 11 to uranium and plutonium is insane. It's like comparing a firecracker to the sun. So break this down for me. What exactly is Particle 11? The paper called it a meson.
Right. Think of a meson like a tiny building block within an atom, even smaller than a proton or neutron. Now, Particle 11 is a special kind of meson, a unique combination of 4 other meson types. It's this unique makeup that gives it that off-the-charts energy potential.
Okay, so it's like we've discovered a brand new element, but on a subatomic level.
Exactly. But here's where it gets really interesting. This particle might actually rewrite our understanding of fundamental forces, specifically the nuclear strong force.
You mean the force that holds the nucleus of an atom together?
That's the one. See, mesons usually don't experience the strong force in the same way protons and neutrons do. But Particle 11 seems to break those rules. Like finding a puzzle piece that doesn't quite fit, but it somehow completes the picture in a way we never expected.
So not only could this particle be the solution to our energy crisis, it might also turn our understanding of fundamental physics on its head. I see why you were so excited about this research.
And we're just scratching the surface. Remember when you mentioned dark matter earlier? Well, Particle 11 might be our best lead yet in figuring out what this mysterious stuff is really made of.
It's funny, right? This tiny, invisible particle could hold the key to understanding something as massive and elusive as dark matter. Okay, I need details. The paper mentioned WIMPs.
Right, WIMPs. It stands for Weakly Interacting Massive Particles. Basically, a category of particles that scientists think could make up dark matter. They're massive, hence the name, but they don't really interact much with normal matter. It's why they've been so hard to find.
So they're like cosmic ninjas, hiding in the shadows of the universe.
That's a great way to put it. And get this, Particle 11's mass is right in the range that physicists have predicted for WIMPs.
So we might have actually found a particle that fits the description of dark matter. Incredible.
Now hold on, it's not quite that straightforward. The research suggests Particle 11 could be a WIMP, but we need more evidence to be sure.
Okay, that's fair. But the possibility is still mind-blowing.
Absolutely. And it gets even weirder.
Weirder? How so?
The research explores this idea that Particle 11 could actually exist in 5 dimensions.
5 dimensions. Okay, now you've lost me. I can barely wrap my head around 4. What does it even mean for a particle to exist in 5 dimensions?
Basically, they're saying that Particle 11 doesn't just exist in the 3 spatial dimensions we experience, up, down, left, right, forward, back, but also in 2 additional dimensions, beyond our perception.
Okay, that sounds less like physics and more like something out of a mind-bending sci-fi novel. How do they even begin to explore a concept like that?
They use these complex mathematical models and something called tensor state numbers.
Yeah.
They're like coordinates, but for these extra dimensions.
So these tensor things, what do they tell us about Particle 11 in these 5 dimensions?
They essentially suggest that Particle 11 might be interacting with these other dimensions in ways we can't even imagine. They ran simulations using these tensor state numbers, and the results suggest that Particle 11 might be influencing the universe in ways we never thought possible.
Okay, this is officially blowing my mind. So we've got a particle that could solve our energy crisis, might be the key to understanding dark matter, and could even be interacting with other dimensions. What's next? Build a spaceship powered by Particle 11 and go exploring those other dimensions.
Not quite yet, but the researchers did simulate how Particle 11 might interact with light, and the results were fascinating.
Okay, I'm all ears. Tell me more.
So imagine a cosmic magnifying glass, That's kind of what we're talking about with Particle 11 and light.
Okay, I'm intrigued. How can something so small act like a magnifying glass on such a massive scale?
It all comes back to gravity. Massive objects, even tiny ones like Particle 11, can actually bend light.
Huh,
It's called gravitational lensing. Imagine a bowling ball on a trampoline. Creates a dip, right? Well, massive objects do something similar to space-time, causing light to curve around them.
So particle 11, with these supposed five-dimensional properties and its potential connection to dark matter, could be warping space-time.
Exactly, and the team actually simulated this effect. Figure 2 in the paper compares particle 11 to another theoretical dark matter particle. Seems like particle 11 might be even better at bending light.
Wow, so we could use this gravitational lensing to see things incredibly far away, things we wouldn't normally be able to see.
That's the idea, like using a telescope, but instead of lenses, we're using the warped space-time around particle 11 to magnify things.
So we could potentially see further back in time, observe the early universe in ways we never thought possible.
You got it. And it gets wilder. Some physicists think this kind of gravitational lensing might even let us see other universes.
Okay, well, hold on. Other universes? Are we back in science fiction territory again?
I know, it sounds crazy, but if what we understand about physics is right, and if particle 11 really does have these properties, well, it's not as out there as you might think.
So let me get this straight. We're talking about a particle that could revolutionize energy, unlock dark matter, and maybe even give us a glimpse into other universes, all from something we can't even see.
A lot to wrap your head around, right?
Yeah.
But that's what makes this research so compelling. It could completely change how we see the universe and our place in it.
Okay, so we've talked energy, dark matter, other dimensions, even other universes. How does it all fit together? The paper mentions something called a unified framework.
Right. That's where it gets really interesting. See, physicists have been trying to find one theory that explains everything in the universe, from the tiniest particles to huge cosmic structures. This unified framework is a step towards that.
A theory of everything. That's ambitious.
It is. And the crazy thing is, this research suggests particle 11 might be a key part of it.
I'm going to need you to explain that. How does a tiny particle fit into a theory of everything?
Well, they developed this complex equation. It looks intimidating, but it basically connects particle 11 to some of the biggest ideas in physics. Quantum field theory, general relativity, even Einstein's famous E-Mihora-Tars energy and mass are interchangeable.
So particle 11 is like the missing link, the Rosetta Stone connecting all these different areas of physics.
Exactly, like finding that one puzzle piece and suddenly everything else makes sense.
That's an amazing way to look at it. But is there any way to test this unified framework? Or is it all theoretical at this point?
That's where things get really exciting. They actually simulated this whole unified framework, including particle 11, on a quantum computer.
No way!
And not just any quantum computer. They used the IBM Eagle, one of the most advanced out there.
A quantum computer. We're talking real-world testing now, not just equations.
You got it. And the results were remarkable. Figure 5 shows a 100% success rate. The simulations perfectly match their predictions.
So this isn't just hypothetical. If we can harness this, imagine what we could do. Clean, limitless energy, solving climate change, maybe even exploring other universes.
It's an amazing thought. But even if we never get there, what we're learning from particle 11 is incredible. It's pushing the boundaries of science, making us rethink what's possible.
Speaking of pushing boundaries, you mentioned that particle 11 might react differently to everyday things, like water or fire. The paper had that table. Yeah, table I. It's not every day you see a scientific paper talking about what happens when you, throw a gold bar at a potentially universe-bending particle. So it happens. Big explosion.
Actually, based on the simulations, it seems like particle 11 wouldn't even flinch at gold, water, or even fire. Doesn't seem to interact with them much at all.
So much for my particle 11 powered super furnace. But hey, that's good news, right? It's not going to cause a cosmic meltdown if it touches a glass of water.
Exactly. Seems pretty stable, as far as we could tell.
Okay, so we've covered a lot. Particle 11 and energy, dark matter, the fabric of reality. But why should the average person care about this? It's not like we're all going to be building quantum computers in our garages anytime soon, right?
You're right. Most of us won't be working with particle 11 directly. But this research is so big, it could change everything.
Okay, I'm listening. What does a world transformed by particle 11 look like? Paint me a picture.
Imagine a world without energy shortages, where cities are powered by clean, limitless energy from particle 11. Think of what that means for travel, for exploration, for solving huge problems like climate change.
It's like a utopia powered by physics. Space travel for everyone, no more energy crises. It's almost hard to imagine.
And that's just the start. If particle 11 really is the key to this unified framework, who knows what we could achieve? New technology, new medicine, a whole new understanding of the universe. The possibilities are endless.
I'll admit I'm getting a little swept up in all this, but we have to remember this is just the beginning, right? There's so much we still don't know.
Exactly. This paper is just the first step. Now we need more research, more experiments to really unlock the secrets of this particle.
And speaking of unlocking secrets, you said this research also simulated hundreds of other potential particles, right? What if particle 11 is just the tip of the iceberg?
That's what's so great about science. Every discovery leads to more questions, more things to explore. Who knows what else is out there waiting to be found?
It really makes you think. The universe is so vast, and we're just starting to understand it. It's exciting and humbling at the same time.
Well said. That's what makes this journey so amazing.
It really is. Well, we'll leave you with that thought. What else is out there? What other mysteries could we solve? It's a big universe, and there's still so much to explore. Thanks for joining us for this deep dive. Until next time, keep looking up.